All right, welcome everyone. So today we'll be talking about some introduction to R, but as you probably saw my next slide a little bit, one does not simply introduce R or data science in general in 45 minutes, so we have a lot to cover. So this is just going to be more of a demonstration of the things that you can do in R, and I will give you some resources where you can learn more about R, etc. So do not expect to come out of this room, thinking, oh my God, I got it. I'm sorry, unfortunately it doesn't work that way, but I'll try to do my best, okay? So, who am I? I'm a PhD student at OSU. I'm in College of Pharmacy doing more statistical genomics. I'm also a co-organizer of Our Ladies Columbus. And here's our link. Our Ladies is a global organization for women all around the world who use R, who come together, they talk about R, they introduce each other different aspects of R, and we're really excited, and we always have some new subjects to teach. So please join us if you're located in Columbus, and if you're not, look for an Our Ladies in your own area. Also, here's my info. I'm always happy to connect. And if you have any questions, always shoot me an email, etc. So you should also have these slides in your R, and we will come to that in a second. But you can always get them, just download them from there too. So what is data science? I think it's kind of a blurry definition. So it is actually a teamwork in some sense, but then it needs to be put into one person, so it is actually a difficult task in some sense. But I really like this tweet. This is also an opening loading message in our Ladies Slack, and that's where I took it from. But it was actually tweeted by this guy, John Wills. He's a data scientist in Slack and Apache, etc. And he basically claims as this person who is better at statistics than any software engineer and better at software engineering than any statistician, which is kind of right. So you need to have be speaking in both of those worlds. But I think it's easier to define some sort of a data science workflow. So this is actually from Hadley Wickham's. His name got uttered in the previous talk, which was a Python talk. So it's pretty awesome that they even, they get to say his name. But as you can see, one of the idea is how to import the data, so how we actually get the data in our environment, and then we do some sort of a tidying, and then we transform the data a little bit, and then we do some sort of a visualization, get a sense of the data, do some modeling, and then this is actually a kind of a circular movement. This is where we really understand some of the patterns in the data, and then potentially, eventually, we want to communicate. I would say this is a pretty applicable general workflow. And why R is so awesome, because there's so many amazing R packages that are really incredibly, I think, user-friendly. Maybe that's my opinion, of course, but, and they're just, this R Studio is a really amazing powerhouse that just keeps generating these packages, and they're incredibly useful. And so we will be using some of them today. But I just wanted to let you know that these exist, and so these are maybe a couple of the packages that you might want to look at in the future. And again, another thing why R is so awesome is the community is really great. They're incredibly responsive, they're very inclusive, and Our Ladies is becoming more and more relevant, I think, and they're just literally out there. And they're really welcoming to women, and I really honestly love being a part of this community. So it's always good to check out our stats or hashtag Our Ladies on Twitter to just get some R news related to R or conferences, etc. And so again, you have the slide as well. Where to start? Each of these are links, so you can just click and go to them. Our for Data Science book is again really great. It's from Hadley Wickham. He's the head scientist at our studio. And it literally just walks you through all of these processes. So that workflow that I showed you is actually from this book. It's for free. It's written with Bookdown, another R package, and it's really wonderful. And then another source is DataCamp, and they're really great as well because you can really learn interactively. But I will give a little of a careful thing, I guess, that we've been hearing that they were having some sexual misconduct issues with their G Suite, so I don't know, but unfortunately it's such a good resource that I still felt like I should mention it. And then another one is this Introduction to Data Science book. This is actually from a bioinformatician in Harvard. And again, I think you can either pay a small fee, it's kind of like a voluntary donation kind of thing. If you really want to get the material, it's for free. And then there's our start here. This is a repository from Greg Gorland. It basically lists all the useful R packages that you might use and basically has links to them. That's again another cool one. Or you can come to the workshop that I will be hosting in the next month, basically. You can always just click and register. It will be a fundraiser for Pelotonia, and I'm riding 100 miles this year, if you're familiar with Pelotonia. So yeah, if you're enthusiastic about that, please come, donate to my ride, and then we will be having a 7-session workshop for that. Okay. So before we start, I want to introduce my TAs. Kelly Bryant over there, she's a wonderful art lady as well from DC, and she's also working for our studio. Well, I mean, she's not a TA, but I still feel like I should introduce Amanda Gadro as well. Obviously, she's also in our studio. They're really wonderful ladies. And then, where do I see? Katie is right there, my other Columbus chapter lady, our lady. She's the other co-organizer. And obviously one of the organizers of this conference, but she will also be TAing my class, so if you have any questions, just raise your hand. They should be able to help you. And then Abbas Rizvi, yeah, and he's back over there. He's with the Columbus Collaboratory. He's also ready to help you. Okay, and before we start, just a really quick thing, how we call functions in R. So we will usually have some sort of a function name. We'll be doing something we expect it to do. We'll have some sort of a queue. And then we will have arguments in them. And then to arguments, we will give specific information. It could be either a data, or we want to tell, for example, what we want to do with that function, etc. So for example, there's the seek function that generates sequences. You can get the queue, right? The seek sequences. And to see the details, you can always just type question mark and seek to your console to just get the help. And generally, the seek actually has this kind of a form. So the first argument is from, the second is to, and the third one is by, so the increments. And so, for example, to generate a sequence of numbers from 1 to 10, we would just say from equals to 1 to 10 by 0.5. Very simple, right? So we'll be seeing kind of similar things now in the code. You can also have functions within functions. Or pipes, I should have actually added that. We will come to that. But this is just so that I'm introducing this to you, that you're not kind of surprised. You can obviously put functions within functions. So in this case, I'm generating the sequence from 1 to 10 by 1, and then taking the mean, and then taking the square root of it. Pretty simple, right? Start from the inside, goes to the outside. Nothing crazy. And in order to execute code chunks, and we will come to that in a second, because you will have your R script, for Windows, you can always use Control-Enter. So you can just highlight the lines, or you can just go to that specific line of code that you want to run, and just hit Enter, Control and Enter at the same time, or Command and Enter for Mac. Or you can always use this Run button in RStudio, and you will see it in a second. All right, so now let's rock and roll. All right, ready? So let's go to our RStudio Cloud. So everyone has been successful with opening it. Everyone has access. Can I see the hands, please? Higher, higher. All right, so we have a good amount of people who already have the session up and running. That's perfect. So let's make it bigger too. All right, so the first thing I want to point out here is that you will see these things that are green, right, before the hashtag, which means that those lines are commented out. So those are like little notes for yourself, or maybe some of the code that you don't necessarily want to run right now, but potentially want to run in the future, but they're not basically included in the code. So when you try to like accidentally, for example, execute that line, it's not going to run and it's not going to throw you an error. Otherwise, maybe I will try to execute it or whatever. So that's why when you see my notes, for example, here, when I talk about like the data set, etc., these are all commented out because I do not want to have normal text in my R script. So the things that I want to have in my R script is the actual R language that I will talk about. And before we start, I should jump too much ahead actually, let's talk about these panes. Okay, so what I have here is this intro to datascience.r. This is actually just a simple text file. It's just written in R language, and this is your script. Okay, this alone itself does not do anything. What actually does, the actual R part of this whole thing, is the console right here. So what we need to do is basically put this information in the script, right, by running or executing that code to send it to the console and basically tell R the things that we want to do. Does that make sense? And so we also have this files pane right here. You will see the presentation in PDF. And then we will also see plots, etc., over there too. And actually, my mistake. You might have the console down here, maybe. I just put it on the right, so you can kind of move the panes if you wanted to. And you can do it easily, again, going over here, and then picking console on the right, so that I can see my script, and I can see what I'm executing on my console at the same time, and I have more room. That's why I do that, okay? All right, so luckily, our Studio Cloud is an amazing thing, okay? So we don't need to deal with all these things with installing packages, etc. Because I already shared this environment with you guys, everything is already installed. So I'm not going to install packages, but this is how you would basically install packages in R, right? And these are a couple of the packages I will be using right now. And that's why I commented them out, because you just need to install a package once. And then when we want to load that package into our R environment, we would just use a library, okay, to able to use all of those functions. And if you might, wondering what the package is that I'm talking about here, it's kind of like the expansion pack of Sims. Have you ever played Sims? The Sims? So it's like the vacation pack. Oh, I have more features now. Yeah, basically those are like the more functions that you actually add to your R environment, and allows you to do things faster or just like much easier, etc. So a couple of the packages that we'll be using today is the read Excel, tidyverse. Tidyverse is an amazing thing. Again, if you go to the Hadley's book, you can probably get a sense of it. And then some of the other libraries. Okay, so I'm just gonna execute this, and then you see, yeah, the warnings. We're okay with the warnings. No, don't worry about that. As long as it's not an error, you might want to check them, of course. But I think in this case we're okay. But you see what happened is that I highlighted all of the lines I wanted to execute, right? And then just did Command Enter, and then everything is just over there. Just sent to my console, and now R has the information that I want these packages to be loaded. We're good? Okay. So the example data set we will be talking about today is this academic salary of professors. And it's pretty sad. It makes me think like maybe I shouldn't stay in academia. And it was actually collected to monitor salary differences between male and female members. But we'll get to it in a second. Okay, so this is actually a data set that is available through an R package as well, but I saved it as an Excel because I want you to know that you can easily even import Excel sheets into your R environment. Okay, so if you want to, for example, see how the salaries looks like, you can just click on it. It will just download it for you. Okay, and then you will see that it has two sheets. And then the first one actually gives the descriptions of the columns. And then the second sheet has the actual data. All right? So that's why I will be running this first line to import my data in the R environment. And then all I'm going to do is give the path. So where this, the file is actually located. In this case, it's exactly in the same spot that my working directory is. And yeah, maybe I should add that. You can always get your working directory with this function. Okay, so in this case, we're in the cloud. This is kind of like this place that is for you, and I didn't try to make folders in there. So we're good. We can just give the file name, and then it will know that it's in that location, because that's where our working directory is as well. And then all I need to say is the sheet 1. And then because I know that it has the column descriptions, I will assign this to a variable. So I will call it salaries calls as for columns. So what I'm doing here, as you can see, is this assignment sign, which means that this object that I imported into the R environment now will be called salaries call. So whenever I want to do something with this, I will just use this variable name. Okay? So I will just run this code. Perfect. Look at that. And I can actually already see what's imported, how many observations I have, and how many variables I have. This is something we call a data frame in R. So it's more of a kind of matrix format thing. There's also a matrix in R though. That's a different thing. But let's just stick to the data frame. So you can also just click, honestly, if you wanted to, and see it if you feel more comfortable, with this kind of a more user-friendly view. And then we can also just go and import our second sheet. And then this is our actual data. And you will see we only have 397 observations and 6 variables. We all kind of get the sense of the dimensions so far. So normally, your data probably is not going to be that small. And even if I wanted to see this data, I'm not going to be looking at all 400 rows. So what I want to get is the sense of the head of the data, right? Of course, if you have thousands of columns, that's probably not going to be that great of an idea either. So be careful with like the dimensions that you want to see and print out. You know, it's not going to be a terrible mistake, but just be careful. But in this case, we're good. So I can just do a head and kind of get the sense of what kind of columns I have, right? This is going to be my first step. I imported the data. Now I'm kind of investigating what's going on in here. And I can see that there's some sort of a rank giving professor, assistant professorship, etc. And then there's discipline. And then in the description file, you can see that the discipline A is, I think, for theoretical fields, and then B is for practical fields. And then you can also see years after PhD, years of service. We have the sex, and then we have the salary for 9 months. Okay? So let's start exploring the GSS data. So I'm going to first use, obviously this is just the head, but actually another nice way to look at it is this glimpse function, okay? And then it allows us to, if you have a lot of columns, like I mentioned before, it prints it such that you can kind of see all of those columns at the same time, gives you what kind of things are in it, and then also gives you the type of the data, which is quite important because every function will expect you to have some sort of a specific type of data, right? We cannot do the things that we do with the categorical variables with numerical variables. So in this case, I do see that I have doubles, so they're basically real numbers. And then I also have categorical variables like male, and then the professor, etc. And that's why they're called character right now, okay? And then I will also run this dfstatus function, which is, again, really quickly going to give me, let's run this again. For each variable, how many zeros and missing values I have. I mean, I think these are like such quick, quick checks, and it's such a wonderful function, even this one. It's just so amazing. You can even get the proportions of the zeros. So you will see the Q zeros as a quantity, and then P, the proportion of the zeros, and then the NAs, and as well as the infinite values, which can happen. And these are one of the main reasons for errors when you try to put them in a function. Because function doesn't know how to handle an infinite value or an NA, and then it will throw in there, and you'll be like, oh, where is this thing? I can't figure out. So this is a great first check for that. So in this case, I see that there's some years of service 0. But that's fine, that's a part of the data. I don't necessarily have any missing data. I don't have any NAs. So I'm good with that, I think. And I'm just going to move on. What happened? Okay. This should be splitting out the plots as well. All right, there we go. All right, and then there's this freak function, which is incredibly useful. So if you run, I hope you're not having the same problem I had just a second ago. But it will give you all of the frequencies for all your categorical data, real quick, again, right? We're just doing quick checks. And then it will also print out bar plots of all of them. So right now, I can, for example, see that there are definitely more professors and just much fewer assistant professors, associate professors. These are obviously things to be mindful about, when you're trying to model something. And so here we are, even already started at this step in that cycle of, looking at the data, visualizing it at the same time, looking at our numbers, and then we will just keep cleaning and, kind of moving towards modeling it, hopefully. All right. And then you can see that, right? So with those arrows, you can actually move back and forward of your plots and kind of see what the things that you generated. And another one, and again, this function gives you, again, very summarized statistics for your continuous variables, all sorts of quantiles and variations, means, etc. Again, it's just like one line, real quick, that can actually kind of give you an idea of what your data is. And then here, we can also plot the numbers. So you can get some sort of an idea of their distribution, right? And again, these are very useful steps because if you're not necessarily familiar with the data, these are the first steps I would, for example, take to understand what's going on, right? And then finally, I just put this function in there just as an example, just to print out all of these summary statistics in a really nice way. Again, it's only one line. You don't need to click around. You don't need to do this, do that. It's just so quick. Literally one line, and you can get all of the summary statistics that you need. And then finally, I will just make this little correlation table, just to get a sense of my continuous variables. Do they have some sort of correlation? And it basically, again, in this function, I provide my data, right? And then I just give the name of the column that I want to get the correlations for, and then here we go. Very quick and easy. Okay. So to tidy and transform my data, I said remove missing data, but in this case we don't really have any. And then another important thing is fix our data types. So as I mentioned before, we have characters, which are different than factors. That's the thing in R, right? So the factor is what you actually want to use in a model because that will make automatic dummy variables from those categorical variables. A character is fine if you, for example, have unique IDs that are characters, right? But if you actually have categories in your data that you potentially want to model, then they should be in a factor class. So that's what I'm going to do. And then I will also change the rank column because actually rank in its sense has an order, right? So it's an ordered factor, and I'm going to change that as well. Oops. And then another thing is this. I mentioned about putting functions within functions, but another way to do it is actually using this pipe, which comes with tidyverse and markgritter. And R did not actually have this pipe until recently. And if you're already coding, if you're familiar with programming, pipe probably makes sense to you a lot. But in this case, this is a kind of a newer thing in R, and it's a, I think, big revolution, right, really. It's so great to just have it because it keeps your code very clean. So instead of having all of these functions within each other, I can actually keep piping them. So what it does is basically takes the object or data beforehand and it puts it into the next function. Okay, so we just keep piping it. And in this case, I start with my new variable name, right? And then I have my assignment sign, for example. And then this is going to be my new name for the clean data set, just because I wanted to call it that way. And then I will start with my data. I will put it in this mutate if function, for example. And then this will let me change all of the columns that are characters into factors. Pretty easy, right? Again, it's just so quick, I think. It's pretty awesome. And then I will also do specifically change some of the columns, like discipline. So I know that A is, for example, theoretical, and B is applied. And for that, I will use this recode column. And it's, again, super easy. Instead of reassigning everything, I can really say, oh, okay, A is actually equal to this, B is equal to that. And then let's just change all of those into theoretical and practical or applied. And then for rank, now, I'm using this factor function, for example. And then I will say that it's ordered true. And these are the levels that goes from low to higher. So that now, when I'm modeling it, it actually knows that it is an ordered factor. So it's not just like categories that have equally importance, if you will, but actually there's some sort of an order in that categorical data. All right, so now, even though I did get some sort of summary visualizations from those quick functions, right, for each column, I want to do my own visualization a little bit and keep exploring it, right? So now I will actually use this ggplot, and ggplot2 is a really amazing package. This is one of the main visualization packages in R, again from Helly Wickham. And you can always go to the ggplot2 tidyverse and just for more information. And then you can also go to the reference, actually, where you will see all lists of arguments. And it's amazing because you can do all sorts of customization, and there's literally no limit to it. But ggplot has kind of its own bit of a format, if you will. So again, I'm starting with my data, right? I'm just piping it into the ggplot function. And then, in this case, I'm using this aesthetic function, which is really crucial. So this basically tells me what I want to plot and what the data is going to be for those. So I want the x-axis to be my rank column and my y to be my salary, right? And then I can use this plus. This only applies to ggplot functions. It knows that I want to add a layer to this information now. Because alone, the ggplot function actually does not reproduce anything. So we can just quickly run and just see how it looks like. Oh, I didn't run the previous one. All right, sorry. Let me just run this line. You see, before the plus. It's just empty, right? Because I have not provided what kind of plot I want to plot to ggplot function. So the main function only basically links your data, and it starts a plot. But in order to tell what kind of plot you want to plot, you need to actually give that layer. And in this case, I'm saying that I want to actually plot a box plot. So that's why I have this geom box plot function. And ta-da, real quickly, I can kind of get the sense of the distribution. Just look at the outliers. And it looks like we have some for the professor, but it doesn't look terrible. So this is actually, again, a quick check to see, if you have like weird things in the data and where the levels are more or less. And you can see, as expected, with the rank, they obviously get better salaries, right? Surprise, surprise. So that's the pattern you would like to see. All right, I'm just going to move on to the next one. And this time, I'm actually going to add a fill. So the fill is going to give the color in these rectangles, right? So it's going to fill them with the color. And in this case, I will give as sex. And what it does, it actually splits them, again, very quickly, right? So we can compare the sexes for each of those categories and then see how the seller distribution kind of looks like. This is, again, a quick check for outliers and see how things look. So yeah, it looks like I think we have a really few data points here, and that's why it's kind of like weird and smushed like that. And then we can kind of see that there's some lower salary median for women. But then, I mean, this is pretty sad at the same time. Like, really, a professor is getting maybe like 52 grand for 9 months? That's tough. That's tough business. I don't know. All right. Just to say something about. But again, here I'm just trying to demonstrate that you can do these things very quickly. And if you're just, right now using some sort of a program that allows you to just click around, this is actually, I know it's a difficult way, maybe at the beginning, but it's like learning a new language, right? So the more you actually learn it, you realize how useful it is, and you just start enjoying it even more. So the problem with clicking around is that they can only always show a limited number of options. So it's actually kind of a difficult thing to even design something like that. And I know R doesn't show you all of its options right into your face, but at the same time, that gives so much flexibility for customization of all the things that you want to do in R. And that's another reason you might want to switch into programming rather than using some sort of other software that is more about clicking around. Okay? And then you can also make like violin plots, and all I did is basically the same data, just to see the distribution a little bit better, right? Because we were just using the box plot before. And then it's exactly the same thing, right? All I needed to change was just a layer. I just want to plot a different plot, I just say it, and then ggplot does it for me. Incredibly easy. Okay, and then maybe I just want to look at the numbers again. And because before I actually did see the numbers per column, but now I want to be able to get a sense of how much females and males actually even exist to begin with. Because that box plot that was so smushed and looked weird gave me the sense of, they probably don't have enough data points. And in fact, you can see the number of females are so low to begin with. Like, how are you even going to compare the salaries in this case? It's kind of a tough business. The data points are probably not really much there to, potentially even model it. We will do it nonetheless, but, this is, again, something to keep in mind, that you potentially don't have enough data points. Okay, and then I'll just keep looking, I just want to look from different angles, right? So these plots basically, again, allows me to explore the data a little bit more and gives me like, okay, so for the theoretical, this is basically the differences between the sexes, etc. And then I can see that, for example, applied seem to be a little bit higher in general, right, than the theoretical disciplines. And then finally, I will add something called a facet grid. So this makes all of these different facets, right? So it basically adds another layer to your data and allows you to see different data, all of these different variables in the same plot from a different angle, in some sense, okay? So we can see now that for assistant professors, what are the theoretical and applied distributions kind of look like for each of the sex. So right now, I'm using all three of these columns to basically make this plot. Again, super easy, just made it like that. Try to make this in Excel. That's, it's probably not going to be that easy, I would imagine. It's not going to be 3 lines, all right? All right, and then now I want to get a sense of the numbers myself. And I will just do more exploration. And then here, I'm going to use this, for example, group by function. And this will group all of these columns by basically those categories, and it will give me a count because it's followed by a count function. So if I just simply run this, super easy. All right. I can easily see a summary of the number of data points I have for each of these categories now. So for a professor, a male, and applied, here's my number, etc. Again, numbers look pretty small for females. So that's something to be aware of, definitely comparatively in the data. So again, I will maybe do this, but one thing I'm kind of struggling with basically is seeing the sexes. Like I want to be able to just compare them next to each other, right? So I can do a quick spread function, and that's one of my favorite functions because it makes data cleaning so much easier. And what will it do when I just run it real quick? It will actually spread that female column that was long into a wide format and fill with all of the values that I need. It was just so quick. Instead of trying to, sort it and copy those cells and paste it to the next one in Excel or something. Probably just so much human error that goes in there, right? So this just makes it so much easier to just one line, just add one more thing, and then here we go. My data is just so easy to see and make the comparison so easy. Okay, and I also want to maybe do some summary stats, because even though before I did get all of those for each column, I actually want to see when they're juxtaposed to another variable, right? For each of the subsets, what are these statistics? Again, I can create these very easily with this summarize function, and you're getting the idea of the pipe, right? So we basically have the data, and then we group it by these columns that I want to see, and then I do the summarize function, which will summarize whatever statistic I want, and in this case, I say, I want to get the median of this column for those categories, right? And I will assign that as a new column name for this little table that I will create, and I will call it median years since PhD. Pretty easy, simple, right? And I will do the same thing. I will spread, again, by sex, and median years by PhD that I just created. And then I will also arrange it by the rank column. So let's just run it real quick. Ta-da. So easy. Instead of trying to, calculate this hand by hand for each of those groups, etc., we can actually quickly just get a really summary statistic for whatever columns we want, whatever categories we want, right? So these are really powerful tools for this kind of first step data exploration. And then I can do the same thing for years of service, etc. You definitely get the point, right? So it's very easy, and I think it's pretty easy to clear. It's easy to understand too. Is anyone super confused, completely lost? Okay, so for those guys who were not though, how do you feel? It looks easy, right? Doesn't it encourage you? Doesn't it look just like, oh yeah, why am I messing with Excel right now? Aren't you feeling like that? Another important thing I actually forget to mention is that all of this is open source, so you don't even pay for it, right? It's not like Tableau. Sorry, I know they're the sponsor, but... And then this is just, again, very simple example of potentially how I can fit a model. right? In this case, obviously, I'm interested in the salary, and then I want to see the relationship between years since PhD and the salary, and then I'm just going to fit this very simple linear regression with LM function, and this tilde is basically saying that, okay, here's my response, and these are my explanatory variables, etc. If you wanted to add more, and we will see in a second, you can just put a plus and just keep adding more columns. And then all I have, the other argument, is basically the data I'm using, right? So all I'm saying is that, okay, let's just fit a linear model where the salary is the response, and then here's my data, and then I'm just going to assign that to an object called fit0, because I want to start with 0, okay? And then right away, I can just get the summary from this model. So it will just print out all of the statistics for me, you know, the significance codes, etc. It will give me the R squared, which is kind of sad, but you know. And then I can also visualize this. So for that, I will go back to my ggplot, right? And in this case, I will add this new layer called geom_smooth. I know it sounds like smoothing the data, but you can also provide a method of what kind of smoothing you want. So in this case, I want to do a linear model, so it's going to do that for me. And then you can see that again, in the aesthetic, right? I'm giving X as years since PhD, and then my Y is basically the salary. Everything's good. Very, very simple and clear. Oops. We'll just drag this up. And here's how it looks like. So you can actually see it with your original data points and how your model basically is fitted to that, right? Just to get a sense of it. You can even, it's kind of difficult to see, I know, but you might be able to see it better in your own screen. You also have these little confidence interval. So easy, so quick, no problems, right? I don't even know how to do this in Excel, honestly. I have no clue. I would probably be so lost. Yeah. All right. And then another easy function, again, to visualize these diagnostic, some diagnostic plots, like the residuals, etc., is using this plot function just with the same fit object that I made, right? So I fit a model, and I actually assign that result as fit0. That's actually an object at this point for R. It contains information in a specific structure that R understands and specific R functions understand. And in this case, I will use the plot. Okay, let's just run this before this par line. Okay, let's just run this one. So what it expects me to do is to keep hitting return to actually see the next plot. So just an example. Let me just like, yeah, I see the residuals versus fitted, blah, 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 right? An easy way to just look at all four of those at the same time, in this case, is using this par function, which is, I know it's kind of annoying. I don't want to get into like the details like that, but it's basically visual parameters. And in this case, I'm saying that I want to create a matrix of 2 of 2 and fill any plot that comes after that. And that's what's going to do for me. So if I now run this line and then run this one after it, all right, I'm not big enough. Let's try again. Oh, dear God, all right, they're tough. I'm just too zoomed in. All right, there we go. All right, no, but whatever. You get my point though, right? So instead of actually hitting each of those points and seeing the next plot, etc., going back with the arrows back and forth, I can actually see all of them at the same time. So you have, your, usual diagnostic plots, like your residuals, to get the sense of how your model is doing. And in this case, there's maybe some sort of weirdness, but overall, I guess it looks okay. My QQ plot looks fine, right? It's nothing that crazy. And then you have the scale location to get like there's scarcity, and then you have residuals and the leverage to get kind of a sense of the outliers. But in this case, we don't really have any, so we're kind of good. And if you want to get more information about these diagnostic plots, I also put a link in there from the Virginia University, I think. And you can check it out. It explains these really nicely. Again, these are some of the diagnostic plots I would do after my modeling. So again, going back to that workflow, right? So we do model, we do some sort of transformation, and then we visualize to just get the sense of what's going on in it. And then we have all these tools available to you in R. Okay, yeah, I know we're at the end of our time. So, but you still have the code, and you can just keep experimenting, and that is the most important thing, okay? You're not gonna be able to break anything. Like, literally, you have this workspace right now. You can sign in anytime. You have the R code, and you can always do whatever you want. Always just come and find me. So this was just, hopefully encourage you to get and going with this, because it's pretty valuable. All right.